Peace and mercy and blessings of Allah be upon you. Let us start. Equipment you must recognize in every distribution substation. Let us have a brief idea of different components. Let us start with the transformer. The distribution transformer is a main and the largest equipment of distribution substation. It is basically a static electric device which steps down primary voltage of 33 kV or 11 kV to secondary distribution voltage, which is 415 and 440 volts between phase to 15 volts between a phase and neutral through delta star windings by electromagnetic induction without change in any frequency. The plate specifies the specification of the transformer such as voltage, ampere, frequency, high voltage, low voltage, then impedance volts. Now pause the video and look at the parts of the transformer. Conservator. Equipped with transformer of rating 500 kVA and above, it is a drum containing transformer oil and mounted at the top of the transformer and connected to the main tank by a pipe. When transformer is heavily loaded, the insulating liquid will heat up and it will expand upwards. When the transformer cools down, the insulating liquid is also gonna cool down and the level of the insulating liquid will drop. Buchholz relay. It is a protective relay of transformer. This device signals the fault as soon as it occurs and cuts the transformer out of the circuit immediately. The piping between the main tank and the conservator is arranged so that any gas involved in the main tank tends to flow upward toward the conservator and the gas detector relay. So as you can see, the Buchholz relay, which is connected between the conservator tank and the main tank. Breather. It is attached to conservator tank and contains silica gel, which prevents the moist air from entering into the tank during contraction of oil. It prevents transformer oil from moisture contamination. When the transformer temperature increases, the liquid expands and pushes the air out of the conservator tank and out through the breather. As you can see the direction of air. In the opposite, we could see that as the temperature is cooling down and the liquid contracts. As it contracts, it is drawing air inside the conservator tank through the breather. The air is going to be drawn through the holes at the bottom of the breather. So as we zoom in, you can see the passage of air through the holes, in or out. Now at the bottom we have oil trap. Oil trap prevents the foreign particles from entering into the conservator like dust, and you have various other particles. Circuit breaker. They are mechanical switching devices capable of making, carrying and breaking current in normal and abnormal conditions. During abnormal conditions, such as when lightning strikes on the transmission tower, circuit breakers isolate the faulty components of the system to prevent additional damage. Ideally, in closed position, a circuit breaker should work as a perfect conductor to ensure optimal current flow. In open position, circuit breakers should act as an insulator and able to break the current instantaneously. Circuit breaker features fixed contact, moving contact that are housed in arcing chamber and open or closed by the operating mechanism. When the contacts open, an arc is created due to the current interruption. Every arc extinguish at every zero level and reignites individually after crossing the 0 point due to the presence of voltage across the open contact. In order to avoid arc reignition, the contacts must be separated at sufficient speed. So that is the arcing chamber. Lightning arrestor. Lightning arrestor is the most important protective device of distribution substation to protect valuable equipment as well as working personnel. The interesting bit is down here. It is a device called disconnector. Yeah, this one. These blow up in abnormal conditions and disconnects the current flow. Yeah, this black. Breaker. It has a lever that allows switching. This is the lever. So when you push it down, it disconnects from the line. It is temporarily locked by a nut and a bolt. Now try to observe the movement of the isolator in the complex group. See, they are being disconnected by the line. इंसुलेटर का ये काम है कि वो इंसुलेट करना सर्विस लाइन को स्ट्रक्चर से या पोल से. Then you have capacitor bank at the load side, then grounding and distribution panel at the end of the load. I visited a site rated 33 kV slash 0.433 kilovolt, that is 433 volts. So at the top we have lightning arresters, and next you have air breaker. You can see the lever, and that is the holder from where you do the switching. This part on which the man is walking is power line fuse. I call it high voltage fuse. So you can read 33 kV, so you have 12.5 amperes working on, you can work on that. So whenever there is over voltage condition, they blow up. So this is the service line.